Thank you for being here. I'm going to talk to you about rollouts, Canary rollouts, and AI. I'm not going to talk about it, but I'm going to show you how can you automate progressive delivery rollouts, Canary rollouts, using AI to do automatic production fixes on the fly. So bear with me. I'll show you this at the end. So I'm a principal scientist at Adobe, Carlos, and work on the Adobe Experience Manager cloud service running on Kubernetes. It's Kubernetes all the way down. And I've been, you may know me for being around for a long time in the open source community, Kubernetes, Jenkins, Maven. Probably you use it at some point. So before I start this, who's here is using Kubernetes? Please raise your hand. Like everybody? Okay. Who is using some sort of Canary deployments on production? Just a few people. Okay. The rest, well, you will see how you can do it easily. So progressive delivery, I'll start with an introduction. It's a name that is kind of new, but it includes techniques that have been around for a while. So it's all these deployment strategies that try to avoid these all-or-nothing deployments. So you don't want to deploy something to all your customers at once in case you break something, and then you want to do somehow progressively make changes in production. So on this progressive delivery world, you want new versions to be deployed to not replace what you have, but run in parallel for a period of time. And then you receive live production traffic and then decide whether the new version behaves correctly for whatever term of corrective means. And if that goes through, then you consider the rollout successful. If it fails, then you have a way to roll back quickly. I'm old enough to remember this from like a year ago, when CrowdStrike deployed something to production and took down half of the internet. And so this was CrowdStrike saying they deploy some content, and then they realized this broke everybody, and then had to roll it back and involve a very hard rollback mechanism. The root cause analysis here was very interesting to read, and one of the things that they came up with as how to avoid this happening in the future, like blameless postmortem, we want to learn from not only our mistakes, but other people's mistakes. And one of the things they said was, here somewhere, the new template instances that have passed Canary testing are to be successfully promoted to wider deployment rings. They call it rings, other people call it waves, but basically you deploy somewhere, you check that that's correct, you add more customers, check that that's still working, and keep adding these rings through different rings, depending also on how critical these customers are. Other companies will do it like internal employees first. You deploy to internal employees. You can do this based on IP origin, headers, whatever you want. And then you do a subset of different customers, maybe something that is low risk first, something that is higher risk or has more traffic later. So, and they allow for baking time between these different deployments to the rings to gather metrics and telemetry, observe what's the impact of these changes before keep rolling it. So you don't deploy to all your users at once as they learn the hard way. You deploy on these waves or rings. The reason you want to do this is you want to avoid downtime. And if something goes wrong, you can quickly roll back. Limit the blast radius. Only a few customers get impacted because you roll small percentages or portions of your user base at once. And it also allows you to get faster to production because you have all these safety nets, and you can deploy things that you know, okay, if this breaks, I'm not breaking everything in production. I may break some internal employees' website or whatever. So that depends on your, I don't know, aversion to failure in your organization. So what are the progressive delivery techniques that have been around? Rolling updates. This is something that Kubernetes does by default. This means every time you make a change to a deployment in Kubernetes, you get a new pod and or a set of pods, depending on how many you have running. When that pod is ready, an old pod is deleted. You get another new pod. When that's ready, an old one is deleted. And that way, if you are always sending a bit of, typically you would send a bit of traffic automatically to these new pods. And as the old pods get deleted, more traffic is handled by the new pods. If you realize that something is broken, you just roll this back, and only a percentage of traffic gets impacted, if you are using just the default Kubernetes way. Blue-green deployment, you have two versions, blue and, well, let's say you start with version 1, which is green here. You deploy version 2, a complete copy on version 2, and at some point you decide, okay, I'm gonna send traffic, you test it, and I'm gonna send traffic to version 2. If everything goes well, you kill version 1. If anything goes bad, you just point the load balancer back to version 1, or your DNS, or whatever it is, and then you have very quick rollback. The problem with blue-green is that you need typically twice as many resources, and you are sending all the traffic to the new version at once when you are doing the switch. So a lot of your users could get impacted before you realize that you need to roll back. Canary deployment is a specialized version where you have an old version, the green version, you have the new version, the blue version, and then you start sending traffic to that new version based on different parameters that you decide, whatever it is. So it could be internal employees go to the new version, or a percentage of traffic, 5% of the traffic goes to the new version, and then you keep moving this percentage until you reach the whole production, and then you start. You can delete the old things as you move forward. You can delete the old stuff. So you also have a quick rollback. Not all the traffic gets affected if you make a mistake, and if I forgot what I was going to say. You can very granular. You can have very granular control of what you are sending to the new version, and you could do this over minutes, hours, even days if you wanted to. Probably not a great idea, but you could do it. Dark launching is another variation of this, where you are getting new features and only allowing those new features or new version to a specific set of people. So you launch something and you only let some people see it. And feature flags is even more granular. It's not so much as the operational level like the other ones, but you can combine this with all the other ones too. You can have feature flags saying, oh, I want to deploy, I'm gonna make this new feature, but it's gonna be off by default. You split code deployment versus feature enablement. Typically, when you deploy a new version, old style, new features go in, and people can start using them. With feature flags is, okay, I write a new feature, I put it in my code, but it's not enabled. I ship the code, the feature is dead, not enabled, And over time, at some point, I can say, oh, I want to enable this particular feature for this group of people. And then you enable that flag. It could be using feature flag servers. There's open source ones. There's open, I think it's open feature flag, one of them, open feature. Or you can do just basic environment variables, anything like that, more simple. But this is very cool because it allows you to enable features for specific customers without enabling them for everybody. See how those work. Maybe you don't know if you are going to be able to cope with the load when you make a change or not. So you can enable it for only a percentage of the users. Check the load. Okay, the load is good. Oh, it's more load than we expected, or it's causing some errors here and there. We can stop the feature flagging, and then you can fix it and keep iterating. And it allows you to ship faster because these things, then you can quickly enable and disable them without having to do a new whole deployment process, build, test, deploy, and so on. So I like to say that monitoring is the new testing because you want to know when users are experiencing issues in production. And more importantly, you want to react to these issues automatically. So if you have good metrics or good feedback, you can react to these things automatically. You can roll back things automatically based on metrics, for instance. And something that happened to me, and if you haven't automatically destroyed something by mistake, that means you're not trying to automate enough, right? You always try to automate more things, and then at some point you're like, okay, maybe I went a bit too far. I need to step back. So how does this apply in the real world? In the real world where every one of you here uses Kubernetes. So on Kubernetes, there's this service architecture where you would have a load balancer, you would have traffic going from that load balancer outside of the cluster into services, and from those services into pods. That was the initial service architecture of Kubernetes. So different pods have labels, and based on those labels, they are grouped on services, and the load balancer, depending on which headers, domain name, whatever, it goes to one service or another. There's the ingress architecture that is more recent, where you have an ingress layer on the Kubernetes cluster. And this is like any other Kubernetes service, where when the traffic gets into the ingress layer, then based on rules, and you have more flexibility than with the previous model, you could send some domains to some services, some paths to some services, some headers to some services, and you can do a very fine granular configuration. So this helps when doing things like Canary. You have a bunch of ingress controllers. Every cloud provider has their own, like AWS, GCE, and then you can have open source ones that are based on Nginx. Ambassador is based on Envoy. Istio, which is a service mesh, also has their own ingress, HA proxy, and so on. So you can choose whatever one you want, whatever one works best for you. Now enter Argo Rollouts. Who's here knows about Argo in general? Wow, okay. Pretty much everybody. Argo Rollouts, not CD, just Rollouts. Okay, just a few people. Okay. So I guess everybody heard about, most people heard about Argo CD, maybe Argo Workflows. There's another project from the Argo community called Argo Rollouts that provides these advanced capabilities of doing blue-green, canary, analysis, experimentation, all these progressive delivery features into Kubernetes, and it allows you, it's very easy to do. So you can do blue-green, canary. Canary analysis is where you decide based on metrics or some backend, is this rollout something that needs to be rolled back or not? Is this something good to go, or it needs to be rolled back? Experimentation is very interesting because you can say, I want a new version to run for a period of time and then kill it, just to gather metrics. At Adobe, we were, I think one of the ideas was maybe we can run Java upgrades. So you want to upgrade Java, you think you got it, you run it for a few hours, gather the metrics. Is this providing the same response rates as the old one? Is the latency good? All these things are going well before actually rolling out. So these experiments has a lot of potential to do this sort of testing whenever you want. How Argo works is you have a rollout controller, like in any Kubernetes controller, and you have a new object that is called a rollout. This rollout defines what analysis to run based on analysis templates. So you could say, okay, a template is go to Prometheus, check for this metric, and make sure that this metric is over this value, so or under, or whatever. So you could say, I want, go to Prometheus, I want 500 errors to be under 1% in order to consider the new version successful. So when when you change the rollout object, or you can have the rollout linked to the deployment, when you change the rollout or the deployment object, and I'll show you this in the demo, what Argo does, it creates a different replica sets. Replica sets are the underlying object behind deployments on Kubernetes. So you have a stable one, and Argo creates a canary one, and then it increases based on the rules you set on the rollout. It increases the number of pods in one and decreases the one in the other. So over time, you will have more canary pods, less stable pods, depending on the rules you set. If you are using service mesh or any advanced ingress that Argo rollouts supports, you can also do very fine-grained routing. So you could say, I want requests with this header to go to the canary. I want requests with this going to this path to go to the canary. You can do more advanced, fine-grained selection of traffic. So some of the things that are supported is Prometheus. Kubernetes jobs is very interesting also because you can just do whatever you want in this job. You can tell Argo, launch a job. Hey, Dimitris. You can tell Kubernetes or Argo, launch this job, and in that job you can do whatever you want. And if that job passes, Argo will consider that the rollout is passing. So you could check some backend, you could go and check some database, you could do whatever you want. So it's very flexible in that sense. And let's do the demo, and bear with me because it's gonna be. Let's hope it's easy to follow. We're gonna have some source code that is deployed. We're gonna have a canary running. There's gonna be an analysis. And in this demo, instead of doing an analysis with Prometheus or anything, I'm using AI. Why would you ask? Why do I use AI? Because I can. And because otherwise the talk would not get accepted here, right? So you are using AI for log analysis. It has use cases. You will see. So AI, I send in the logs to an LLM. I'm using Gemini in this case, Google Gemini. And then the AI will tell me, okay, based on these logs, should I promote it or not? If I promote it, it goes to production. If the LLM tells me not to promote it, it rolls it back automatically. And then there's going to be something else that needs to be done by a human, probably. So bear with me on the demo. I'll try to show you what I have here running. Okay, so I have the demo running here. And I have a service. Okay. I have a rollout. Can you see it? Fine, yes. Okay. So on the left-hand side, you can see the Argo gives you a bit of a command line view. And it's for some reason it's blinking too much. Or it's just blinking. Oh no, it's only blinking in my screen, so you're good. And I have this version called blue here, and it's returning blue on the website. So if I go and do, I upgrade, and I'm gonna upgrade directly, changes the image name because YOLO. I'm gonna set the image to green, and my rollout process is very quick, just for the demo. Every 10 seconds is gonna go to 20% more and more. So over time, I'm getting more green dots, and because I'm getting on the left-hand side, I'm getting, well, it's blinking there too. I'm getting 2 new pods. I'm getting, I have 4 old pods now 3. And it's switching, creating more new pods that are taking more traffic. So the new pods are green, the old pods are blue. And here at the bottom, I have the logs, but let's wait. It's in weight is 60, so it's 60% out of 100, and it's 20% every and 10 seconds wait between things. So if I go and get analysis run, this is an object that Argo does, that creates. I can see an analysis run happening in the last 57 seconds. Let's wait, see if this finishes okay. We are now at 100%. So all the dots are now green. So it went through the rollout, everything was fine, it moved. How it was decided that everything was fine? Let's describe this analysis run. And Gemini, I send the logs to Gemini, and Gemini tells me, okay, here it is. The stable version consistently returns to 100 blue. The canary version returns to 100 green. Both versions return at 200 status code. Based on the logs, the canary version seems stable. Nothing too complex, but this is just the demo. But this gives you an idea of you could ask for more complicated things if you wanted. Now, let's see, what else can I show you here? Let's say I want to deploy a new version that is not so good. So it is doing the same. 1 second. This version is going to return multiple colors. And so the rollout is starting, and there is 1 pod running the canary. You're getting some random colors in the middle. And here is now 2 pods are running the canary. And the old ones is, it was 4. But here, if maybe I should stop this so it stops blinking. Yes. Automatically, we can see here that it went back to all green again. So there was a period of time where some traffic went to the new version that returned random colors, and then it went back to the green automatically. I didn't have to do anything, trust me. And here I see degraded on the status. And let's go look at analysis. Wait, what? Oh. Okay, I think I lost it. Split vertically. Yes. So get analysis run. Yes. Analysis run. 90 seconds ago, I have a failed one. And this will tell me why. So the analysis says the stable version returns a 200 status with color green consistently. The canary version returns a mix of colors, purple, blue, green, orange, yellow, it knows the colors, along with several panic errors due to runtime error, index out of range with length 0. This indicates that the canary version has a bug and should not be promoted. The error occurs in the getColor function. So it took the logs of the stable, took the logs of the canary, compared them and says, this is not working well. And I get, my prompt to the LLM is, tell me in a JSON version, in a JSON format, should I promote it or not? And here promote is false. And what confidence level do you have? And here is 95. So 95, he's 95% certain that I should not promote it, and therefore Argo does the rollback. And I'm using the Gemini 2.0 Flash model, and yeah, metric fail, the result is failed, the analysis result is failed. Analysis run. Okay, so these are the two. The two in the middle are the ones from this demo, and one was successful, the other one was failed. Now you say, okay, this is interesting. I can do more complex things to analyze logs, analyze anything you want. And I can use an LLM to do it, not just because it's more expensive, but it will provide some value, hopefully at some point. If we go here, the other thing that this plugin, I gotta say, this is a plugin for Argo Rollouts. You can write your own plugins. This is, I put it open source, and the intention is to get it contributed to the Argo project. This plugin, what it does also, so if I go to my demo, Rollouts demo, 3 minutes ago, I created a GitHub issue for me. So what it said in my plugin is, if the promotion fails, go and create a GitHub issue go to the LLM and say which title and which content should the issue have. So the LLM has created, Gemini has said, okay, canary deployment failure analysis, the canary is failing due to a runtime error, blah, 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 results in 500 errors, multiple colors, it's getting confused with the colors because it's different, that's fine. It's showing a runtime error with a length 0, and the panic suggests that this function is trying to access an element at the index 0, which makes sense. Stable logs, canary logs, and the panic. So, and a bunch of recommended actions. Now I got an issue automatically created. Okay, that saves some time. But what else? I can do assign to copilot. That sometimes it works automatically, sometimes it doesn't. Need to figure out why. But okay, I'll assign it to copilot. Oh, a server error. It's the internet. Okay, now it's assigned to copilot. But the one thing I did was label it with this Jules label. So here, Jules is a Google Labs coding agent that you can invoke in your issues and will basically go and fix them for you. Same thing as GitHub Copilot. So Jules says, oh, I'm on it. You will see another comment. I'm ready for a review. So between 5 minutes and 3 minutes, while I was talking, maybe having a coffee, maybe just not doing anything, it did create a PR for me. Copilot, it was a bit slow because I had to click on it. Let's go to the pull requests. So the two ones that were created, one was okay, so the 2 times I clicked, it went the 2 times. But let's go to this one. By the way, you can use, there's Jules from Google, there's Copilot from GitHub, you can use Cloud Code, whatever. If you have the Pro version, you can use also the coding agent. And Jules created this pull request that says, okay, fix 29, I can, yeah, you can talk to me, whatever. The test is failing. Like, I'm so disappointed in Jules now. It removed all the section that I added. I had to add an error that was not very obvious. So it removed the whole section that I added, which is good because that was useless. But for whatever reason, the tests are not passing this time, which is surprising. Maybe it was some, we can take a look here. Oh, make didn't. Successful. Imported and not used. It didn't remove an import. Okay, great. This is not useful. So this is the Jules interface. If we have time later, we can go for it. Come on, Jules. And if Copilot, what does Copilot? Same thing. It goes with a plan. And initial plan, it started working 1 minute ago, so that's going to take a little bit. It hasn't done any changes yet. So we can go and look at the Canary, the Jules, make it bigger. So it's basically what you would do in your local laptop with one coding assistant. It just does it for you on an issue, a PR, and comes up with this, with whatever suggestion, creates the PR, updates the PR, and so on. So let's see. It's too bad because I cannot merge the fix. This one is the broken one. But if we look at the previous one here from Jules, what did it do? Here it changed, it did it a little bit differently. It fixed the problem, didn't remove the whole section that was useless, and added a test. So depending on which time you execute it, you get different results, as with everything AI. And Copilot in the previous one, it did remove the strings import, remove the function, and also added a test. And I think this passed. Yeah, the one interesting thing with Copilot, it doesn't let you run the workflows automatically. You have to approve them because I guess GitHub doesn't trust they don't want you to trust it too much, maybe. And so I have to approve the workflows for it to run. So I'll show you. This is the Argo Rollouts UI, where you can see the steps. So it was 20%, pause for 10 seconds, 40, 10 seconds, 60, 10 seconds, 80, 100. So this is what you can define it completely. I'll show you the code. But you also, not only you have the CLI, but you have the UI here. And this is Cloud Build. That it did build 20. No, this was this morning, right? Okay, and Cloud Deploy, because the idea was if this passes, I go and click on Merge. And this is the plugin. I'll give you the links in later. Come on. So this is not yet working, not yet suggesting something. So yeah, Copilot is still in one of 4 tasks. Still a bit stuck in there. But we could do, this one was the good one, because you could do as many as you want, and you can even tell each other to review each other's pull requests. So let's go and merge this one. Yeah, I don't care, YOLO. Do I need to update? Because this was, let's squash and merge. Yeah. The good thing is that you get nice code comments and nice GitHub logs. So, okay, this pull request fixes this critical thing, whatever, and it fixes everything and adds a test, so it must be good. I trust you. Okay, so this keeps running, and let me show you then a bit of the code here. Okay, so the rollout with AI. It looks pretty much like a deployment, and on Argo rollouts you can do the canary seed analysis. You pass which template uses this, which template to use for the analysis, and then you start with the steps. Here in the steps, set weight, 20%, pause. I think this is an old one, but doesn't matter too much. Set weight 40, set weight 60, set weight 80, and then pauses in between. And then you have the whole deployment specification from Kubernetes standard. So you can also point it to a deployment. So you can have rollout and deployment, and in the rollout you say, okay, just control this deployment. The interesting bit here is you have two things. You have labels where you can say label the old pods in a way and label the new pods in a different way. This is very nice for, let's say you want to have a preview of what you are deploying, of the canary. Or you want to send all the traffic of your employees, internal network, whatever, to the new version. You can route that traffic to the new version based on the labels that Argo sets. So you have the pods labeled in both ways. And the other thing is the templates. I go and look at the template, and in the template I say check every 10 seconds. So every 10 seconds is doing the analysis. I want the result to be over 50%. So if the confidence is over 50, if the LLM tells me to promote with a confidence over 50%, just do it. And this is the plugin that I wrote, where I say I want to use the Gemini model, and this is the GitHub URL. This is needed to create the issue. And when Argo does the rollout, it calls this plugin to do things. And the plugin is, these are the examples, is a Go project where you can do no, not this one. This is the plugin is using HashiCorp Golang plugin format, and the interesting bits is okay. This is all the initialization. This was most of it. It was vibe coded. I want to create an Argo plugin, do it like this, and I want to function this way. So the AI part is analyze logs with AI. The prompt is analyze this canary behavior and respond me in this specific format that I want to understand, and to give me a number between 0 and 100, telling me how confident you are of the promotion or not promotion. You can also pass extra prompt. I think I did it here. So on the AI analysis template, you could say whatever you want. I think in this example I said, don't care about the color return because it's going to be different. So you could pass a specific prompts additions whenever you do this. And the plugin has two ways of working right now. One is inline, so this plugin goes and queries the LLM, gets the promotion or not promotion information, goes to GitHub, creates the issue, but also has an agent mode where instead of doing all that, it goes and calls an agent using A2A. And this allows you to build an agent that understands your problem space better. So you can give it access to tools. The agent, the initial agent has access to kubectl, but you could add more tools. You could add have a different agent that has a different context information or more internal data, or I don't know. You want to go and go into the database, go into Jira, go into some other tools. You could do that. So that allows you to chain agents and do these more advanced use cases. So let's look here back. If where is this standing? Okay, this still failed. Still here. This was merged. Let's see if this built. 336. Yes, this was built. This was had to be deployed. Yeah. So for some reason, okay, let's get the analysis runs. And in the last 2 minutes, it still failed. Okay. Why did it fail this time? The stable version. Okay. The canary version is behaving differently than the stable version. It could indicate a bug or a new feature that needs further investigation. Since the color is ignored, the variety of responses suggests an unintended change, and thus the canary should not be promoted. I told you to ignore the color. What did you not understand? Anyway, so you can see that it works perfectly all the times. What should have happened is that it would just deploy automatically for you. So let's see. So you got it, right? You got all the things in the middle. So what was at the end of this loop, and this is what I think is important for AI and agentic workflows. You need the loop that allows the AI to understand where it has errors or where it has successes. So after the rollback, now creates the GitHub issue, gets one of these coding agents, whatever one you choose. You can also say, use an LLM directly and say, okay, clone the repo, make some changes, push it and whatnot. But all these tools now give you coding agents, generates the pull request, creates the code changes, and you go back into the loop. So I'm guessing if this works, I get another issue saying, 3 minutes ago, saying, we got the wrong colors, right? And now I have Jules working on it again, and I'm going to have it working 24 hours until it fixes it. And that's the thing, right? I can go and have a break, and no problems. It's just magic. Oh, it's already, the PR is already fixed. Okay, what did you do this time? Instead of random color, just return green. Perfect, I like it. Ready, yeah, it's ready. I thought about saying, just automatically merge it and everything, but then it would be too fast to show. Yes, okay, you're done. So an issue that was created some time ago, and now it's fixed. Everything works fine. So I think this is where the future goes, is you don't want to work in one thing at a time. You have the machines that can work in 20 things at a time, and you just need to review that what they do is what you want them to do, which not always going to be the case, but there's a lot of tedious tasks that we have to do that we don't want to do. And so with that, I hope you understand a bit how you can use in a more practical way AI with some more of the code, the development and deployments and integrating the whole picture a bit. And I saw this picture. I was like, I cannot not put it in the presentation. So this is the world we're going to. So rolling out changes to all users at once is risky. Canaries allows you to move or feature flags, and a combination allows you to make this safer. And you can use AI agents today to automate this loop, solving the issues for you and automatically fix them. So this is totally possible today. It's not science fiction. And I, for one, welcome our new robot overlords. And yeah, those are the URLs where you can get the code. The barcode is for the feedback of the session. If you think it's good, that's it. If not, that's not the right code. And so, yeah, thank you. I'll be around if you have questions later. Thanks.